Hello students. Today we're going to look at some kinematic problems, and the first thing that you're going to want to have open is the worksheet on the left hand side of your screen. That was in the assignment inside of Schoology. If you bring that up, you'll be able to work right off of that as I go through it on the screen, because in a moment I'm going to move it off the screen to give us a little more room to work on our problems. Now keep in mind, any of the work that we have today on the screen, you need to have on your piece of paper as well. All right, that means that we're going to follow the guess method. We're going to put in all the units of measurement. We're not just going to put down the answer. All right, the only way that you get credit is if you show how we come up with the actual answer itself. Okay, so let's go ahead and get started. We'll begin with the distance and displacement worksheet. We'll begin with those 6 questions right now. So we have the first one. I'm going to assume the name is Janice. Janice drives her scooter 7 kilometers north. All right. And what I would do is, on your paper, it says to use graph paper, but we're not going to use graph paper. We're just going to put down our number. It says 7 kilometers north. So I'm just going to draw a vector diagram. And I'm going to put here 7 kilometers, so put 7 km. And then it says that she stops for lunch and drives 5 kilometers east. Now, to the east would be to the right. So we'll have 5 kilometers here. It says what distance, so this is part A, what distance did she travel? Well, that's pretty simple. You have 7 kilometers and 5 kilometers. All right, that's 12 kilometers total. Okay, pretty straightforward on the first part. But the second part, what is her displacement? Her displacement is going to bring up something that we are going to get to. It's called the resultant vector. The resultant vector is right here. All right, see the displacement for part B, it says how far, displacement is how far are we from our starting point. Well, we started here and we ended here, so if we did a straight line path between those 2 points, how far did we go? This is a little bit of an introduction to what a future chapter is going to be. And this is going to involve you using the Pythagorean theorem. Right? We have a right triangle that has been formed here. And all we have to do is just label our sides. We have side A, we have side B, and we have side C. So the Pythagorean theorem, if you haven't done it already, A squared plus B squared equals C squared. So we're trying to find that displacement. So I'm going to take the C, and we're going to get rid of that square by square rooting both sides. All right, so we'll plug our numbers in. We have the displacement is going to equal the square root of side A, which is 7 kilometers. And we're going to have to make sure that we square that, right? Squared, plus we have side B is 5 kilometers. Again, you have to make sure that you square that as well. We're going to put the calculator up here so that way we can see what would be the best way to put this into your calculator. So I'm going to hit the square root button. I'm going to use a parentheses. We'll go 7 squared plus 5 squared, and I'm going to close that, and it equals. So the displacement is 8.6. So put that in here. We have 8.6 kilometers. Now, here's the deal. Displacement has both magnitude and direction. And we're just looking at the introduction to this. So we have the magnitude part right now. The magnitude. The direction for this right now, we're not going to go into any trig in determining the angle of this just yet. So all we'll say for now is that this is in the northeast direction. All right, so we'll keep it simple at first. We won't do the trigonometry to figure out the angle. We'll save that for a later unit. Let's go to question 2. Question 2, it reads, if I get that out of the way, question 2 reads, Anthony walks to the pizza place for lunch. He walked east 1 kilometer. All right, so we're going to go east 1 kilometer. And then they go south 1 kilometer. So we'll have 1 kilometer here. And then they go east again 1 kilometer. So we have 1 kilometer here. Our questions are, what's the total distance that this person has walked? Well, I'm going to save you the problem of having to write this out. 3 kilometers is the distance that they've walked. But we have, what is the displacement? The displacement now, well, our starting point was right here, and our ending point was right here. So if we do a straight line, just like we had done before, that dashed line right there is my displacement. But I don't have a right triangle to solve for this to use that Pythagorean theorem, but I can create one, can't I? If we look at this, I know what the distance is because that is 1 kilometer down. And then if I just come across like this, what did I just form? I formed a right triangle. And what's the distance right here of that green vector added up together? Well, if that's a kilometer and that's a kilometer, that means that's 2 kilometers. Now we're ready to put that into the Pythagorean theorem. I'm trying to find the longest side, side C. So I'll have the square root of 1 squared, and that's kilometers, right? And I'm going to put that written in there correctly. So we're going to go plus, we have 2 kilometers squared. All right. So again, calculator time, so that way you know how to put this into your calculator correctly. We're going to go square root. We have 1 squared plus 2 squared. Close it up. And you have 2.2. We'll leave it at 2.2. So we have 2.2 kilometers. And again, we are not going to use the trig to get the direction. Instead, what we'll do is we'll just get a generic direction that this is pointing in. So this would be pointing in the southeast. Do not get used to us just using the generic directions because later on we are going to be more specific with it. So we have question 3. Question 3, on his fishing trip, Justin rides in a boat 12 kilometers south. All right, so this one right here will point south 12 kilometers. And the fish aren't biting, so they go west 4 kilometers. So right here we have 4 kilometers. What distance did they travel on this fishing trip? That's the easy part. We just went 16 kilometers for the total distance. Now, for the displacement, we go from where we put pencil and paper together first. That's our start point. And we draw a straight line, well, the dashed line, to where we ended up at. Okay, so we formed that right triangle again. So I'll make this a little bit quicker this time. So for part B, the displacement, I know that I'm trying to figure out the square root of 12 kilometers squared plus 4 kilometers squared. All right, so our calculator, we'll throw this up, and we have square root of 4 squared. Oh, we don't need to put that parentheses in there. Maybe I do. We'll go 4 squared plus, what was it, 12 squared? 12 squared, close it, equals, we have 12.6. So 12.6 kilometers. And for this to be displacement, I have to have a direction. So this would be to the southwest as a generic direction. We're halfway done with the top part. We go to number 4. Number 4, it says Tara goes on a camel safari in Africa. She travels 5 kilometers north. Okay, so we'll go 5 kilometers north, like this. Then 3 kilometers east. So we'll have 3 kilometers east. Then it says 1 kilometer north again. So we have just a small one right here. That's 1 kilometer north. It says what is the distance that she covered? So part A, our distance here, we have a total of 9 kilometers that she would have walked. But let's get to that question. What is the displacement? So she started here, she ended there. So we're just going to do a dashed line connecting those points. All right. We don't have a right triangle, but you can make one. So I'll come over, and then I'll come up like this, and I have my right triangle. I know that this side right here, we'll do that a little better here. There we go. So I know that that side is 3 kilometers because that's the parallel side to it. And then I know this side right here, we had the 5 here, and we have the 1 there, so that whole side is 6 kilometers here. So we'll use the Pythagorean theorem, where we'll take the square root of your 5 kilometers squared plus the 1 kilometer squared, and we will come up with, as soon as I get my calculator going, well, I guess it's going to be done a little quicker that time. So we go 5 squared plus 1 squared equals, we have 5.1 is what we'll go with. Okay, so we have 5.1 kilometers, and then we have to have a direction because every displacement has magnitude. This is the magnitude, and then we have to have a direction with it. The direction is to the northeast. We have number 5. Number 5 now says Alex goes cruising on his dirt bike. He rides 700 meters north. Okay, so we'll have 700 north and 300 east. So we'll have 300, and that was meters, east. And then 400 north. Oh, this is going to be a long one, isn't it? I should have drawn this in a different spot. Okay, we'll make a little more room. So we have 400 more north. So we'll have 400 north right here. And then we go 600. We have 600 meters west. And then 1,200 meters. Woo. So we have something like this, because we have 7, 4, that's 1,100. So 1,200 would be just past this. So this would be 1,200 meters south. Then we have 300 meters east. So about halfway, 300 meters east. And lastly, says finally 100 meters north. All right, so we're going to have to be careful with this one right here. So I'm just going to put 100 because I'm not sure where this is going to lie. All right, so 2 things. We have part 1. What's the total distance that we have traveled? So I'm going to cheat here so that way I don't make any mistakes on this. You have 700 plus 300 plus 400 plus 600 plus 1,200 plus 300 plus 100. We have a total distance that he would have been dirt biking of 3,600 meters. Now we get to that part where we have the displacement. How far away are we from the starting position? All right, now I know looking at this that if this part right here is 600, all right, let's think this out. I know that they went to the right 300 here, and then they went back 600, and then they went back over 300. So that means that this line right here is in the same path as this right here. Okay. Then if we're looking at our distances here, we have those two right there. We have 1100, right? That's 1100. And then you add this part right here to the mix. So that extra 100 gives you 1200 meters that would have been traveled in the y direction. Well, if they went down this way 1200 meters, what is our displacement? We don't need any math for that, because what we did is we ended up right back at the starting point. So our displacement is 0. We go to number 6. Number 6 here said Jose buys a new moped. He travels 3 kilometers south. So we'll put this in here. We'll have 3 kilometers south. And then they travel 4 kilometers to the east. All right. How far does he need to go to get back where he started? Now, that's asking what's the displacement. Okay. The displacement, how far does he have to go if we did a straight line path? What's the distance between those 2 points right there? So we use the Pythagorean theorem. Again, that's a squared plus b squared equals c squared. We're trying to find out what this side is right here. That's the displacement. So we have the square root of 3 kilometers squared plus 4 kilometers squared. All right. Calculator time. We bring this up. We go square root. We have 3 squared plus 4 squared equals, and it comes up to be 5. So Jose would be 5 kilometers away from where he started. And this says, how far does he need to go to get back? Well, if he's standing right here, if he's on his moped, he would have to go to the northwest to get back to where he is. All right, so this did not say what was his displacement. This is just saying how far does he need to go back to where he started. Okay, it is the displacement, but we're not saying that we want to know from where he was to where he ended up at. We're saying where he ended up at, how far does he have to go to get back to where he started. All right, that's the first half of your homework right here. The second half of the homework, we'll go ahead and start this right now. This is calculating speed, time, and distance. I'd really recommend, if you struggle with any type of algebra, rearranging equations, I'd really recommend that you start with this at the top of your paper. We'll have speed equals distance divided by time. All right. We are going to have to rearrange this equation. I really want this in your formula sheet, by the way. But rearranging equations may not be your strong point. So what we can do is we can use a little helpful guide like this right here. All right. We're going to see in the question, or in the formula, that distance is on top, right? So that means I'm going to put distance on top. Then I'm going to see that I have time underneath the division symbol. So I'm going to put time right there. That means the only thing that's left is the speed. And we'll see how we're going to use that throughout this. We'll begin with question number 1. Question 1, it reads, a motorist travels a distance of 406 kilometers. So That's the G. We're only going to put the actual word guess down for this first one. And then after that, we're going to assume that you know exactly what the steps are. If you don't know what the steps are, it's at the top of the worksheet, right? So we have the given of 406 kilometers. That's going to be our distance. And then we have a time of 7 hours, and that is going to be our time. It says, what is the average speed? Okay, now this is a two-part deal. So we have the average speed is going to be in part A. It says kilometers per hour, and then part B, it says meters per second. So we're going to have to do some factor labeling here. The equation, we know that the average speed, now you're going to notice I put this down two different ways, S and the V with the little line atop of it. As long as we know what the variable is that we're dealing with, it shouldn't be an issue. We could put X there for all intents and purposes. So we know that our speed formula, speed equals distance over time. Okay, so we'll plug these in. We have distance over time for this. Our substitute, you have 406 kilometers in a time frame of 7 hours. So if we plug that into the calculator, what we should end up with is, and you need to check me also when I'm doing this, we come up with a velocity of 58 kilometers per hour. Now that's only part one. Part two, we have to convert kilometers and hours over to meters and seconds. So we need a conversion factor for that. 1 kilometer represents 1,000 meters, and 1 hour represents 3,600 seconds. All right, we're going to put those in. Now we're just going to add to this. We don't need to redo the whole thing. We don't need to reinvent the wheel because we have the work. We just have to put in the conversion factors. So we've got the first one. We have kilometers right here, kilometers here. So that means I'm going to grab this portion of the conversion factor and put it down there. That means the rest of that goes in the top. We have then hours. Hours is going to cross cancel with hours. So this portion of our conversion factor will go in the top. That means the rest of that goes in the bottom. So I have my calculator handy. We're going to take that 406 times 1,000 divided by 7 divided by 3,600, and we get 3,600, 16.11. So for part B, we have 16.11 meter per second. So that's our first problem. All right, we'll go to question 2. Question 2 has, we have during a canoe race, a camper paddles a distance. Okay, so we have a distance of 406 meters, and then our time is going to be 70 seconds. It says, what is the average speed in? All right, so again, when we're trying to figure out this speed, it wants us to figure out two different units. It says for part A, it wants it in meter per second, and then for part B, it's kilometer per hour. So we need the formula. Same thing as before, distance over time. So our velocity, you're going to have 406 meter in 70 seconds. So for part A, we'll have 406 divided by 70. It's going to be 5.8 meter per second. Now, when we go to change that, again, you need the conversion factors. You have 1 kilometer is 1,000 meters. 1 hour is 3,600 seconds. Okay, so we'll extend this. There's no reason to redo the whole setup. we're just going to add in the conversions. I have meter, I have meter. So that means that that portion of my conversion factor gets cross-canceled down here, and it didn't take the 1 with it. There we go. And that means that the rest of this goes on top. We go to the other one. We have seconds. We have seconds. So that portion of the conversion factor goes on the top. And this is going to get kind of bad. Here we go. Let's try this. And the rest of the conversion factor goes on. I knew that would happen. Whoa. The rest of this is going to go like that. All right. So what we do is we multiply that out, divide it all, and we should come up with, if I did this right, 20.88. But that, let's see. Yeah, it sounds right. So we'll go for the velocity for the second part, 20.88 kilometers per hour. All right. We'll go to question number 3. Question number 3, we have, excuse me, number 3 says a rocket is launched into outer space and it has a distance of 240,000 kilometers. So distance, 240,000 kilometers. And we have during the first 6 hours, so the time is 6 hours. It says after launching, what is the average speed? And again, we have a 2-part thing. So we need what the average speed is in part A. It's asking for kilometers per hour. And then for part B, it's asking for meter per second. We need a formula, distance divided by time. So we'll start plugging these variables in. 240,000 kilometers divided by 6 hours. So our velocity here, that should be 40, I'm not going to, 2 divided by 6, so 40, yeah, 40,000. Okay, so 40,000 kilometers per hour. Now we need that conversion factor. So the conversion factor, changing the meters, 1 kilometer equals 1,000 meters. And then 1 hour represents 3,600 seconds. We'll match up our terms, plug it in, and we should be set. This time, let's just do this a little different. Let's take the hours first. Let's get rid of the hours first. So to cross cancel them, cross it up. That means the rest of this goes down here. Then I move over to the kilometers to get rid of kilometers. I'm going to grab that portion of my conversion factor, cross it down. That means the remaining portion goes in the upper right. So when we go to solve for this one in meter per second, we'll go divided by 3,600 times the 1,000 equals, we got some extra zeros in there. We got 11,101 meter per second. Okay. We have question 4 now. Question 4 says that you have an electron in a vacuum. An electron in a vacuum with a length of 2 meters. Okay, it's going to travel the length, in that length it's going to travel is 2 meters. So our distance equals 2 meters. And it's going to do so in a time of 2 times 10 to the negative third seconds. All right, what's the average speed in meters per second and centimeter per second? So we have velocity, and this is going to be for part A, it's going to be in meter per second, and then for part B, it's centimeter per second. So our formula, distance over time, if anything, just you going through and writing down that formula over and over, it's repetition is how you learn. So if anything, writing this stuff down, it's going to help you memorize it. All right. So we have velocity. I know it's 2 meters. We have a time of 2 times 10 to the negative third seconds. So I'm going to actually put this one on the screen here so that way we can see how we properly use that scientific notation. You go 2 divided by 2. Do not hit that times 10 and the caret button. There's an EE button on your calculator. That represents the times 10. We're going to go negative 3 equals, and that's going to give us a velocity of 1,000 meter per second. Now, our next part, we have 1 meter equals 100 centimeters. We don't need to do anything with the unit of time because it still says it's in seconds. So we only have one conversion that we need to do here. I want to get rid of meter. I find it in the conversion, and we cross cancel. That means the rest of that goes up top right like this. So my velocity in centimeters per second, we're just going to add 2 more zeros onto this. So we have 100,000 centimeter per second is what we'd have. All right. We'll go to number 5. Number 5, it says that we have the light from the sun requires 8.3 minutes to reach the earth. So 8.3 minutes, that's going to be our time. And then it says the speed of light is 3 times 10 to the 9th, but that's a typo. That's not right. The speed of light is actually 3 times 10 to the 8th meters per second. So let's use the right thing. That's going to be velocity. And it's going to ask us what's the distance, right? What's the distance? Yeah. It's saying, what is the distance from the sun to the earth? But it's going to want that in kilometers. So we do have to rearrange our equation now. And that's where that little diagram at the beginning would come in nice and handy if you struggle with rearranging equations. See, we had distance, time, and speed here. And if I'm trying to figure out what the distance is, if I cover that up, I notice that velocity and time are side by side. So that means my equation is going to be velocity times time. Now, if you are good with algebra, you can rearrange the equation yourself without the aid of the little diagram by simply multiplying both sides by the time to cross cancel it. So whichever way works for you, use it. All right, let's plug the numbers in. We have distance, we have the velocity, 3 times 10 to the 8th meter per second, times our time of 8.3 minutes. We have 2 small issues here. Our units of time don't match up. Minutes and seconds, we can't multiply those together. We have to have a conversion factor to do that. So I'll put this down at the bottom. We have what do we got? Minute. 1 minute equals 60 seconds. And then you have to change kilometers and meters around. All right, so I'm gonna do this because I just like seeing this with the bookshelf. It keeps everything nice and clean. All right, so we have the first one. Let's get rid of the meters first. So meters, I see meters here. So I'll grab that part, and we're gonna put that in the denominator. Why? Because the meter was in the numerator at first, so to cross cancel it, it has to go down there. That means the rest of this is gonna go up top like that. Now, we have one more conversion factor that we have to put in here. And we're going to get rid of seconds. So I see seconds right here. So I'll grab that portion, cross cancel it. That means the rest of the conversion factor goes in the bottom. All right. Now, we're left with multiplying this all out to figure out what your distance is. And since this is dealing with some scientific notation, let's put it in the calculator to make sure we're doing it all correctly. So we'll plug this in. We have 3 EE8. Now that represents the 3 times 10 to the 8th. We go times 8.3 minutes. We have divided by 1,000. We have times 60 equals. We have 1.494 times 10 to the, we got 3, 6, 7, 8 kilometers. All right, so that's number 5. Number 6 says a bullet leaves the muzzle of a rifle and 5 seconds later, so I see 5 seconds, that's telling me time. It becomes embedded in a tree trunk that's a distance of 3,000 meters away. It says, what is the average speed of the bullet? So we're trying to find out what the speed is, and they want it in, of course, meter per second and kilometer per hour. All right. Our velocity, distance over time formula, we can plug in our numbers. You have 3,000 meters in a time of 5 seconds. So our velocity here is going to be 600 meter per second. All right, you take your 30, divide it by your 5, you got your 6, and then we just add the other 2 zeros. So you don't have to always have a calculator for it. Now we need a conversion. We have to convert this thing, get rid of that meter per second, and want kilometer per hour. So same old conversion factors. 1 kilometer, 1,000 meters. 1 hour, 3,600 seconds. All right. We'll cancel out the meter first. So meter here, that means that portion, I don't think I grabbed the one, that portion, if meter is in the numerator, that means I have to cross cancel it in the denominator. The rest of that goes up top. If I want to get rid of the seconds, I find seconds in the conversion factor, and I'm going to cross cancel it. It goes in the numerator. The rest of my conversion factor goes in the denominator, like that. So we'll take your 600 times the 3,600 divided by 1,000 equals, we have a velocity here that's going to be 2,160 kilometers per hour. All right. We're all finished up with the problems today. What you have to be aware of is I'm working through these, but you have to be able to do these on your own, because when it comes test time, you're responsible for doing them on your own. So if at any point today you were having some troubles, you were having some questions, you need to ask. I'm more than willing to help you out, but you have to be willing to ask and get some extra help if you need it. All right. What you need to do now is put your name at the top of the paper, take a couple pictures of your work, and then submit them to the assignment in Schoology, and we're good to go for the day. All right. Take care.